Hello everyone, welcome to the Mammothon tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Program Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the program, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
I'm Jordan. I'm the CTO at Astria. And kind of the order of operations here, I want to start by kind of talking about what Astria is and kind of the tooling and whatnot that we have built around it such that you can build on top of it, and then dive into our idea here for the Mammothon project and kind of go through that before moving on to Q&A. So building with Astria starts with kind of, what is Astria itself? And there's a couple of different, at the bottom of these slideshow, it's an old slide deck, it says the shared sequencer network. These are all kind of terms we have used. We talked about it as a shared sequencer, a sequencing layer, and I've said in various presentations over the last year or so that it's a based Rollup platform. And all of these are fine, nice words, but what does it kind of mean? So as these words have changed, what Astria is under the hood hasn't really changed. It's just a matter of trying to help people understand kind of what we're doing. And so what Astria is a layer here that's designed to give you early confirmations, and similar to how Celestia is solely focused on providing the highest amount of DA available, Astria is a layer solely focused on giving you a canonical ordering to your transactions, such that when you're building a rollup, you can rely on it to get everything, to provide transaction order, to provide kind of a decentralized service for sequencing your transactions. So as a user, you can be a participant in various different rollups, as we see here, shown by like the red kind of mixed and orange rollups. You submit your transactions for the rollup you're using through into the Astria shared sequencer. This is a normal transaction for a blockchain, and then those get put into a single block. That data gets posted to Celestia, where the kind of one of the differences here between using Astria and using Celestia is that Celestia orders things based off of what is maximally efficient for your for getting DA out, using blobs and squares and all of this, trying to maximize data throughput, whereas Astria is focused on how can we actually get all of these transactions ordered and kind of batch together in a single batch. We also do faster block timings. And then you can read the transaction ordering off of Astria as well as off of Celestia, where we get, kind of a firm commitment to the data, providing it with a broader data availability network, making sure that everyone can have access to it. And then you can run your rollup over the state machine. And so the reason I've kind of called this like, we call it, a sequencing layer is kind of our normal now. We used to call it shared sequencing because you're sharing all of this. And I've talked about it being kind of a based rollup platform. And that's kind of based off of some of the stuff that comes out of ETH World, where Justin Drake had this quote: "Rollup is said to be based or L1 sequence when its sequencing is derived by the base L1." And this instance, what really gives this the ability for you to just build a deterministic state machine and not focus on everything else is you just derive the order of your transactions out of the base layer. And so I'm going to talk about kind of a little bit. It sounds complicated when you see this, but we've built a lot of tooling to make it as simple as possible. So that's what I'm going to kind of start with talking about on top here. And, people smarter than me have come through here and kind of said that, this is a nice idea. What if we had ETH rollups that used 2-second block times and were designed for single slot finality? This happens to be exactly what we've built. And so, I mentioned it seems kind of complicated when you look at a bigger diagram, but how does this actually work for the rollup developer? And so as the rollup developer, you get to kind of focus on two. We can divide this up into kind of 3 subsections. There's Celestia, which is underneath all of this, and then you have the sequencer network, which exists, and then you have your rollup. And within the rollup, the only aspect that we want developers to actually focus on is this red box, the rollup itself. And so we've built these 2 components called the conductor and the composer. And what these are designed to do is to really make it as simple as possible for you to build your own rollup state machine. And so what the conductor does is it reads data off of the sequencing network and off of Celestia. It's entirely agnostic to what sort of format your data that you post is available in. It does validation of the data posted that it reads for the soft commitments off of the sequencer network, as well as validating the data that it reads off of your namespace in Celestia. Puts that all together and then just drives via an API up to you in the rollup. We call the execution API. You implement this API and you can implement whatever state machine you want. We have examples and, we'll talk about kind of our Mammothon ideas here. But right now, we have a Astria Geth kind of implementation that does this. But we've also done things with NoVM in the past, which is one of our Mammothon ideas here, as well as, experimented with integrating with Cosmos SDK and whatnot. And then we also have the composer, and the composer is here for when you're building a sovereign rollup. You may have some opinions over how you want to order and execute transactions. Composer provides the ability for your rollup to kind of own this. And so while users can submit their transactions directly through to the sequencer, the composer provides a way for you to provide essentially a gas station, which is, we'll pay for the cost of posting the data down here. And we get to build into that some ideas about the kind of ordering of how transactions should work. And this kind of gives this, like, as a sovereign rollup, you can still have ownership over some of your sequencing rules and things which you want to do, but you have optionality of going straight through to the sequencer with no delay in terms of how those transactions get included. And this is from the Lazy Chain team that put out our announcement. These are some of the projects that are kind of built on top of Astria. So I know, unfortunately, Forma isn't able to give their presentation today, but Forma is built on top of Astria. And then we have Flame, which is built on top of Astria, and we're working on getting Lazy Chain out here in the near future. So when it comes to actually building on top of this, again, I've said we've tried to make it as easy as possible. What does this actually look like? And so, there's a life cycle here and kind of a standard development life cycle. And some of these aspects that we're going to kind of go over is like, you have to build, you have to do testing, you have to do deployments. And it kind of, when you're developing an application, it's very cyclical. And so we've tried to build tooling to make it as easy as possible for you to do different parts of this. So on the build end, you know, it's all about how do we make it as easy as possible for developers to move through and get everything done here. And so, as I mentioned before, we have this execution API. There's documentation up in Buff, and we'll have show you some links to where all this stuff is documented. But the basic idea here, this is a protobuf gRPC API that allows to be very easy to build out kind of wireframes in whatever language you choose to build your rollup in. Try to be as agnostic as possible to what you do there. And then these, like, you know, the core of this is really the execute block request and execute block. There's some other stuff in terms of startup and whatnot here that's, again, try to keep it as minimal as possible. But if we dig into what the execute block request is, it's transactions, and transactions are just bytes. So you can use whatever format you want with that. And then we also put together this development CLI, because there's a lot of components, and one of the things we hear, especially, you know, building in the modular space looks a lot like in Web 2 building with microservices. One of the difficulties is building with microservices is, okay, I have to run this and I have to run that and all these pieces. So we built this development CLI. It gives you optionalities in terms of how you want to run and test. So in this instance, and I know it's a little bit small here, but I can potentially do a small demo here at the end. We have an instance of the sequencer that's running along with Comet BFT. And then we also have an instance of Composer and Conductor that are all being operated by the CLI. It's a single command to start up all of these tools. And then when you're going through and working on your rollup, making changes or anything like that in the hot path, you can just restart, reload, and continue working. Like, okay, I have some changes. I want to see how it affects it when I go and I restart. And you can just keep doing that restart loop while running this as a tool alongside you, so that it's as easy as possible to run everything. You can go and kind of look through all of these different components, so you can see, okay, my transaction didn't go through, it didn't execute as I was expecting. Is that because of what layer? And it's like, okay, you can go and you can look and you see, okay, Composer submitted the transaction through, Conductor got it. Let me go look at my logs for my local tool. Try to make that as easy as possible. But after you've built a tool, you have to go and you have to deploy it. And how do we make it as easy as possible to deploy things? So there's a variety of different ways that this can be done, and admittedly, it's going to depend on your own app. But for us, we've leaned internally. Again, I said this looks a lot like microservices. We've leaned a lot into doing microservices via Kubernetes for a lot of our deployment tooling. And so we've put together a series of Helm charts and commands in a charts repository that, depending on your rollup, can be updated or built on top of to work on getting into this kind of production deployment state. And tried to make this as easy as possible too, such that you can test locally as well as deploy. So, you know, in this example, when you use, we use these just file scripts, but as long as you have like Docker and such running, some tools installed locally, you can run just deploy sequencer or run a sequencer on your local machine. And you can just deploy, you know, a rollup. In this instance, it's deploying an Astria Geth version. Make this as easy as possible for you to iterate on. And then this tooling can then be applied to, you know, you can use your preferred environment, whether it's self-hosting or running on, you know, AWS or GCP or anything that offers you kind of Kubernetes instances, and you can spin this up and then you can get, you know, replicated services and make it as easy as possible to manage. And then you also need to test your application. And so we've built some tooling here for generating transactions that go through. So, you know, it's nice in terms of a development flow. Maybe you want some manual transactions, but maybe you just want some sort of scripts and whatnot to go through and run and say, what I actually want to do is, you know, it's nice to see that a single transaction goes through, but what I need to do is bombard my application with 10,000 transactions from different sources, put together this spamware with the idea of doing exactly that. And then we have the concept of like, how are we going to integrate with other partners? You know, we have all these different chains built on top of Astria. How does that work? Well, we have this idea of kind of an enshrined bridge as well. And so these are the kind of the actions of types that you can do inside of the Astria sequencer itself. you can create a bridge account. That data is then whenever funds are locked into it via that execution API, there is information funneled up and says, hey, you received new deposits. And that goes through. And so you can immediately just kind of integrate as simply as possible, as long as you can process that deposit type transaction. You can do IBC into the sequencer with a single kind of pass-through hop, even all the way through into your Rollup application. And then we have some for the withdrawal, it's a little bit more complicated, but you can essentially create transactions to withdraw from there. We have a EVM built bridge withdrawer. Happy to work with folks for the other end of this. Yeah, so and kind of trying to make sure that it's easy as possible you could integrate. And coming soon, we'll have a bridge transfer such that as you go through and you do this whole process, we have multiple rollups. It's kind of a single transaction. Say, okay, I have my funds in one rollup. I want to migrate them over to another, and kind of native within this Astria ecosystem, making it as easy as possible for you to switch between different spaces. And then, yeah, so this is also what powers if you use Flame uses this bridging mechanism. You can have IBC connections via the IBC connections that we have in the sequencer. You can do bridging via Celestia, Noble, Osmosis, Stride, and Neutron. And kind of you go to like bridge.astria.org, you can see this, and it allows you to deposit funds and withdraw into Flame. And then usually when you're building a rollup, the next part of this would be to decentralize. But when you use Astria, you already have decentralized block production. And so that's kind of it's like, okay, how do we make it as easy as possible for people to build a rollup? You know, when we talk about coming back up to the top here, this rollup, if you look in terms of like what's inside of the Optimism code base, for instance, a lot of that code is here in Conductor, what we call Conductor, they call the OP node. A lot of the code that's actually makes that more complicated is there because we're built on top of a single slot finality system with the sequencing network. It's a lot easier to build this, but also we provide it out of the box in a generic manner. You know, if you're using Optimism and OP node, it uses the engine API, which is unique to how Ethereum works. This is designed from the get-go to be as generic as possible, so that kind of as a builder, you have as much freedom as possible to go through there. And so without, diving too much, I want to kind of shortly here run through some of the tooling and docs, and then talk about some of our Mammothon ideas. Cool. So in terms of, I talked about a number of tools and whatnot here. So, and I'm going to share some of the documentation and whatnot we have here, and then go through kind of the Mammothon ideas. So I mentioned that we have this, Rollup development CLI, the Astria Go CLI. In general, at docs.astria.org under the developers tab, you'll find some information about there's two different CLIs here, information about the deployment charts and the testing tools I mentioned. The Rollup development CLI, we have kind of information here about kind of the general setup. We also have within the tutorials, information about how you can run a local Geth rollup, as well as kind of will be relevant to Mammothon, this kind of NoVM messenger rollup that we've put together, kind of a demo as a baseline concept for. And so just wanted to kind of show that real quick here. And then I can also, if we give me just a second here, I'm going to screen share something else here. Give me just a second. All right, so I mentioned, we have this this utility for running things. So this is going to run here, actually, the NoVM rollup that we put together here as a demo. And so I can put together let's call this demo message. And what we have is just a CLI for interacting with this right now. And we can submit through here, and we can see, sending a transaction. it's kind of this is unfortunately a known thing we're working on fixing, but the error is ignorable here. But we can look and we can see in Composer here, we can build out into the actual, like, dig into the logs here. We see that a bundle got submitted. We can look at conductor and see that, you know, new blocks have come through and been executed. And then even inside of our rollup itself, because this is running the rollup through the CLI in this instance, see that that's gone through. And then we can run a query here, and we can see kind of the messages that have been sent through since I started this up like 15 minutes before this call. So you can see the basic concept here of, you know, you can use the CLI to send a message. It gets encoded into a series of bytes, which, you know, not formatted in a superhuman readable way, but we can generate and see kind of all these messages coming through, and utilize the CLI here to run through and view everything. All right, I'm gonna switch back to our slideshow here. Cool. So our Mammothon ideas, I gave a quick rundown there of kind of what we've put together. And this is, you know, we call it a NoVM messenger rollup. And what does it mean to be NoVM, right? I think in general, when we think about blockchains today, we think a lot about us building out these environments for generic compute. You know, when you use Ethereum or you use Solana or anything like this, a lot of these are, and a lot of Cosmos chains use CosmWasm, right? It's built around this idea that I can run my arbitrary software on a globalized, decentralized network. And we think there's an opportunity here building on top of Astria and building sovereign rollups, especially where it can be a lot simpler to not have a VM integrated into everything you're doing. And instead you can build just, you know, right now, if you're building a new protocol in terms of a VM, you end up writing something that looks like Solidity. It's a little bit more complicated. There's lots of edge cases and foot guns, and you're concerned about gas costs and how that gets computed. Oftentimes we're sacrificing performance by doing this, right? Because inherently, if I am writing a program that then runs inside of a virtualized environment or something else, we have some performance costs to that. So when we're building a sovereign application, it's like, okay, we're building application logic. Why don't we just actually write the application ourselves and in whatever language we want? You know, in this instance, our demo here of the NoVM that we've put together in here in this tab, it's a Rust-based system for the chat app and has, you know, a CLI built in Rust. But, you know, you could build in whatever you want. We use Rust a lot in the Astria team internally. So when we talk about the NoVM, it's okay, why don't we just build our own custom application interfaces? The reason we don't do this oftentimes has to do with integrating with various wallets and utilities that are kind of on the periphery, which we already have access to. But if we want to build something that's more performant and provides potentially opportunities for new types of functionality that isn't really possible with a EVM, for instance, you could do deferred execution type things where you say, okay, I'm gonna submit a message, and it's only going to become available if and when someone pays, you know, some fee, or you can have this concept of escrow accounts that automatically settle. Right now, when you do escrow accounts in a EVM, typically you need to like put money into the escrow, and then eventually you have to submit a transaction to claim the things out of the escrow. You could have these be automatically settled. You can do a lot of kind of more standard app logic, which happens based off of your own fee pricing model and have full control over that without having kind of this exogenous load of, okay, I'm running against something else. It's kind of the upside of building a sovereign application. And so, you know, the messenger rollup is kind of a fun idea here, just because it builds into a lot of what we have for existing kind of, we think about how do we in the crypto community create discourse, right? And we're constantly in Discord and on Twitter and on X, or whatever you call it these days. And we don't necessarily have there's been versions of applications and social media platforms and whatnot, but how can we create something that's like, okay, something native that's for your own ecosystem, and even within this mindshare, right? You could consume some information out of other people's Astria namespaces. So you could look and you could say, oh, what I can see is that this person has this NFT on this other network. And those people who have access to this NFT are able to participate in this messenger application as kind of a small subset. And getting back to, sort of the principles of how, and, messenger, I think is kind of an interesting, it's the basic application that we first see on the internet. We see IRC channels and we see all these different things. So this is the basics of our NoVM messenger application. And we also put together at a previous time, we built a separate kind of, we have the Rust example. There's also an example in Go that we put together, which was this like 8bit.chat is currently, you can still see what it looks like, but it doesn't currently work right now. But it was this, kind of anonymous message, and you could just come in here, hit send, it was posted. And you can still read all of the messages off of the network, but it was on an old DevNet, and we haven't upgraded to utilize any of the newer ones. But this kind of existed as an example of, okay, it's just like a place where you can come and post, and it posts all the data to Celestia underneath. So, it's broadly available for the future, and continue to be able to like see the information posted there. Yeah, I think that's what I have here. I know we're supposed to go over one Mammothon idea, so won't dig into the others here. But that's what I have for presentation-wise here. I think I ran through that pretty quickly here, but I think that leaves us some good time for Q&A.
Yes, that does leave us lots of time for a Q&A session. So for everyone in the crowd, if you're interested in the Astria ideas and building their projects for the Mammothon, and you have any questions, now is your time to ask. This is the best forum for you to get answers straight away. If you're still considering what ideas you're thinking of building out in the Mammothon, which one you're going to commit to, then this is the opportunity to ask about some of the basics for why Jordan thinks you should think about building the Astria ideas. So if we have any questions, please put them in the chat. I see a couple of people typing. So we'll give you the opportunity to type out your questions. So Mohammed has asked, we've been thinking about building a chat message app like WhatsApp. Would an Astria Rollup be a suitable platform for that? I'm thinking about message speed, scalability, fees, etc.
Yeah, I think, my answer here is going to be like, yes, I do think Astria is a suitable message. I think it depends on the, when we talk about speed, scalability, and fees, right? The scale of WhatsApp, when you think about the scale of building something like WhatsApp, I think it depends on what your actual like target is. If you're actually saying, I want the number of transactions and the amount of data that's going through WhatsApp, then you have to start thinking about like different opportunities for how you can scale that. Because just like, frankly, in a globally decentralized network, which is globally replicated, like you're not going to have every message of WhatsApp data available everywhere on as fast as you want. What you can instead do, if you're thinking about like super high scale, is thinking about how can we do something that looks more like a ledger of evidence versus all of the data, and potentially posting some data off chain. But for a starting place, Astria is functioning currently on 2-second block times. In terms of, what we see in terms of like real-time messaging, like WhatsApp's not getting you your message faster than that. Fees and whatnot is fairly, like our fee structure within Astria is fairly minimal. We just cut the baseline fees on Flame to a tenth. I think it's less than a penny to do a full Uniswap swap on Flame, and that's running with some margin of error on overall fees. So I think that's totally feasible.
Mohammed did follow up, but you did already kind of answer most of the question. But just for the recording, Mohammed followed up saying, we're thinking about incorporating AI capabilities as well. The main issue is, of course, storage of messages, and that they guess all messages shouldn't be stored on chain, which you did just sort of cover. But...
Yeah. I mean, if I'm building, again, thinking about kind of the overall scale here, in terms of Astria today, and we'll be doing an upgrade here shortly, Astria functions within a portion. We don't currently, good stewards of using Celestia, we purposely limit the amount of data that can go through the sequencer such that we're not going to end up ever using an entire Celestia block. We do compression and whatnot of data before batching and compression of data coming through in order to kind of minimize the amount of data space that we are utilizing. And I could talk more about that.
Sorry.
Let me finish here. I think if you are starting out, having messages posted on chain makes a ton of sense. It's a good baseline. If you get into the point where you have a number of users that's hugely substantial, yes, messages probably have to be off chain, but with some sort of you can do some sort of representation of them, be that hashes or something on chain. I see the follow-up question here. The next question we have here is, Astria shut down our Discord to focus on development. Any place that we can follow Astria's development progress and access with the team, chat with developers? Yes, we did shut down our Discord. I know this is a contentious decision. The reasoning behind this, as we mentioned, was like to focus on development. It was also that like we were focusing on development, which meant that people in Discord weren't getting necessarily the interactions that we desired out of for folks, in order to, and instead oftentimes that it's unfortunately Discords can become a place of third parties introducing their own exogenous ideas of what's going to happen and when things are going to go up and down. And so in terms of a new platform, I know we are talking about putting together a developer Telegram. We have had a couple new people come onto the team who will be more focused on specifically integrating with third parties. For the Mammothon itself, this is kind of I know there's a Discord, and we have at least 2 people on our team that are inside of there to help with people getting onboarded and getting connected. And then, that'll kind of, our model there is that we're not going to have the whole team in there, but there'll be a trusted representative who then, if there's more in-depth questions, we'll pull people in as necessary to make sure we can get you the help you need.
And if you want to find that channel Hexmark for the course of the Mammothon, you should join the Encode Club Discord, which the link has been sent to you when you registered for the Mammothon. And when you join the Encode server, you're asked to select what program you're involved in. And if you select the Mammothon, you'll have access to the Astria zone where the Astria mentors are. And if you have any questions, you can tag their role and they can get back to you and possibly bring in other people to help you out, as Jordan said. If you need a link for the Discord, let me know and I can post that in chat. Mohammed has said, thank you. There was something that I thought about as Jordan was speaking, but I've now forgotten what it was. So hopefully it comes back to me. But if there are any other questions, that was what it is. Earlier, Mammoth Bros asked, is there a former tutorial today? Unfortunately, the former tutorial has been delayed. So it was supposed to be today, but it won't be happening today as of now. So we will try and get you a recording of the former tutorial as soon as possible. The speaker has been unable to come and film it live, but hopefully we'll get some resources out to you as early as possible so that you're ready for the Mammothon when it launches on Friday. If you're looking for information about the former ideas, then I suggest the Discord is the place to look. It's got all of the information from the Hacker Pack about their ideas, and you can also get in contact with the former team alone. Marcus asked, is the Telegram group going to be only for devs working on Astria directly?
The goal here is not the idea of, and again, I don't think we have put this together yet. We're in the process of getting to where we launch this, but no, the idea would be anyone who's building in the ecosystem would be able to participate.
And followed up there.
Yeah, I see the follow up here. Does the SDK only support Rust? Any support for TypeScript? And so this is actually yes, there is support for other stuff, and I'll just go ahead and kind of share here. I mentioned that we have this execution API, and it uses gRPC and protobuf. For those who aren't familiar with the concept of gRPC and protobuf, protobuf is it's kind of two pieces. It is, you have Proto as a IDL, which is an interface design language, allowing you to define your interfaces and whatnot in a kind of abstract manner. If we look, this is the exact kind of format of what it looks like. It is language agnostic. Protobuf is then the encoding format that these get transmitted into over wire. The upside of using Proto as an IDL is that you can generate client libraries and SDKs in many different languages. So we publish all of our protobufs to Buff, which is like a overall schema repository for this. If you click here into the SDKs, you can see, and this is part of why we use protobuf, as opposed to anything that's language specific, is that you can come in here and you can generate in such a way that you can, for various different implementations and whatnot. But if you wanted to do something in JavaScript and types, you can come and you can import and generate base types for things in JavaScript. You can come in here, you can do, Go is kind of probably the most common tooling that you see protobuf and gRPC used with very frequently. But yeah, the reason we actually utilize this is specifically that we knew as a small team, we wouldn't be able to build a client library for everything off the bat, but by building using protos makes it really easy for people to have types in any sort of functionality.